Hello and welcome back to Chapter 1. Today we're going to look at Section 1.3, which deals with linear equations and two variables. One of the simplest mathematical models that we have for relating two variables in a linear equation is the y equals mx plus b format. And if you remember from Algebra 1 and Algebra 2, this is our slope-intercept form. Now the m here represents our slope, and the b is our y-intercept, which leaves y and x to be our two variables. And if we need to calculate the slope of a non-vertical line, it's either, some of you call it rise over run, it's the change in y over the change in x, which is right here, or y2 minus y1 divided by x2 minus x1. So example 1 tells us to sketch the equation negative 4x minus y plus 5 equals 0. This function here isn't in a user-friendly form as it stands, but we can put it in a user-friendly form. And I know we can put it in a user-friendly form because I notice we've only got the two variables. So what we're going to do is we're going to isolate the y variable right here and push everything else to the other side of the equation. So to do that, I'm going to get rid of my negative 4x and my 5 by adding 4x and subtracting 5 from both sides. So we end up with a negative y equals 4x minus 5. I want to get rid of that negative on the y, so I'm going to divide everything by a negative 1, which is going to give me y equals a negative 4x plus 5. And if you remember, graphing an equation that is in slope-intercept form, okay, here's my slope, here's my intercept. All I have to do is start out with my y-intercept, plot that, and then do the rise over run, and we're good to go. So, as we mentioned, our y-intercept is at 5. So if I go up 5 units, I'm right here. My slope is a negative 4, so I'm going to go 4 units down, 1 unit over. 4 units down, 1 unit over. And I've got enough points now to where I can graph this by connecting the points. And I now have a graph or a sketch of my equation negative 4x minus y plus 5 equals 0. We will not always be given an equation of a line as we had in example 1. Even though we're not given that equation, we can still find a slope and an intercept. If I'm given 2 points on a line, for instance, like what I've got right here and here, if you notice, I have from this point to this point, I have some change in x, and we measure a change, remember, by subtraction. So if I take this x2 value and subtract it from this x1 value, I get this change in that distance. Likewise, to find the change in height from here to here, I'm going to take this y2 value and subtract y1 from it to get the total change in height. If I know the change in my horizontal distance and the change in my vertical distance, I will then be able to find this slope between the 2 points. So the slope of a non-vertical line through the 2 points x1, y1, and x2, y2 is y2 minus y1 divided by x2 minus x1. And just as a refresher, we typically designate slope with the lowercase letter m. So let's look at example 2. It says to find the slope of the line passing through the points negative 5, negative 6, and 2, 8. So again, if we use the y2 minus y1 divided by x2 minus x1. Now if you find it helpful, you can call this your x1 and y1 point, and this would be your x2, y2. It doesn't matter which point you call 1 or 2, but it does matter that you keep consistent that your x1 is with your y1 point. In other words, if I pick this as my x1, this has to be my y1. if I make this my x2, this has to be my x2, and this has to be my y2. So now I'm going to go ahead and just plug into my formula, and we have 8 minus a negative 6, and this is all for slope, divided by 2 minus a negative 5. When we simplify that, my negative negatives are going to become positive. And 8 plus 6 then is 14. 2 plus 5 is 7. And if we reduce the fraction, we see that we end up with a slope of 2. Now, if we look at part B, we want to find the slope between the coordinate points 3, 4 and 3, 1. Again, if I label, here's x1, y1, x2, y2. We end up with 1 minus 4. Again, this is our slope. Divided by 3 minus 3, which is going to give us a negative 3 divided by 0. And I want you to stop and think. If I take a number and I divide it by 0, this tells me that the slope does not exist because that dividing by 0 is going to give us an undefined number, so we cannot have that. Now, we can write equations in two variables in a couple different ways. Personally, the point-slope form, which is what we've got right here, this is going to be your most useful equation. It's the one that if you go on to take calculus, even the AP Calc recommends that you use this. To me, this is the best equation. I personally don't like point-slope form. I tend to see a lot more errors when people try to use that. So please, please, please start getting in the habit of using the point-slope form. I think you'll find that it's a lot easier to use and it's more user-friendly. So point-slope form says, if you have a line with a slope, which we're going to call M, and it's passing through some coordinate point, x1, y1, then we're going to go y minus y1 equals the slope times the quantity of x minus x1. Please, please, please remember this equation. I cannot emphasize to you how important it is. This is very, very noteworthy. So example 3 then says to find the equation of the line that has a slope of 2 and it's going through the point 2 or 3, negative 7. Okay, so the first thing I'm going to do is I have y minus y1 equals m times x minus x1. You could technically use slope-intercept form, however, it's just not as user-friendly. So watch this. If I have a slope of 2, and my point, this is my x, this is my y, so I'm going to go y minus y1. My y1 is a negative 7, equals my slope, which is 2, times the quantity of x minus my x1, which is 3. When I simplify this, I end up with y plus 7 equals your slope, which is 2, times the quantity of x minus 3. Now from here, if you really wanted to go and put it in slope-intercept form, which is your y equals mx plus b, you can. And all you have to do is distribute. So we would have y plus 7 is equal to 2x minus 6, and I'll get y by itself by subtracting 7 from both sides. So then we'd end up with y equals 2x minus 13. So now you can see that your slope is still 2 right here, and your y-intercept then is a negative 13. But again, this is like one of my favorite methods to use right here. Okay, now the second part of our problem said to use this information to find 2 additional points. To do this, all I have to do, and because it says 2 additional points and it doesn't specify where they are, I can just pick 2 values of x and plug it in, and I'm going to use this equation right here. And let's just pick a value of x equals 1 and x equals 0. So if I plug a 1 in to this equation, I have y equals 2 times 1 minus 13, which is equal to 2 minus 13, or a negative 11. So one additional point would be the point 1, negative 11. And if I use 0, that's going to give me 2 times 0 minus 13, which is a negative, this is y equals, this will give us a negative 13. So another point that would fall on that graph would be 0, negative 13. Now you could have picked two different x values and that would have been okay as well. Okay, another thing that we can look at when we're dealing with linear equations in two variables are parallel and perpendicular lines. And if you recall from Algebra 1 and Algebra 2, if we have lines that are parallel, okay, the two lines will have the same slope. If they're perpendicular, then the slopes are going to be opposites, okay, in terms of the sign and the reciprocals of one another. So example 4 says to find the equation of the line passing through the point negative 4, 1 and that is parallel to 5x minus 3y equals 8. Well, the first thing I'm going to do is I'm going to go ahead and get this equation in slope-intercept form. So we have 5x minus 3y equals 8. I'm going to move the 5x, so I have negative 3y equals a negative 5x plus 8. We need to divide by the negative 3, and we end up with y equals 5/3 x minus 8/3. Okay, so now what I've just discovered then is I have a slope of 5/3, and because it's parallel to, I know that my slope has to be the same, and I now have my slope. I was given a point, so I'm going to use Pointslope Form, which says y minus y1 equals m times the quantity of x minus 1. So I have y minus my y1, which is 1, equals my slope, which is 5/3, times the quantity of x minus a negative 4, which is x plus 4. And you can leave it just like that. Or if you want, you can continue on and put it in slope-intercept. But I will accept it just like that. Part B then says to find the equation of the line that passes through the given point and that is perpendicular. Well, we've already got the equation written in slope-intercept form up above, so we know that we have y equals 5/3 x minus 8/3. For a line to be perpendicular, we know that the slope has to be the opposite sign, so this is going to be a negative, and the reciprocal. Well, the reciprocal of 5/3 is 3/5. So now that I have my slope, I can go ahead and use Pointslope Form again and say y minus my y1, which is 1, is equal to your slope, which is now a negative 3/5, times the quantity of x minus a negative 4, which is really x plus 4. For example 5, it says, when going, and this here should be down a mountainside, warning signs indicate the road has a grade of 12%. This means m, or the slope, is equal to 12 divided by 100. We want to approximate the amount of horizontal change in your position if you note from elevation markers that you have descended 2,000 feet vertically. If we go ahead and draw a sketch of what we've got going on here, we know that because we're on a mountainside, we have descended 2,000 feet vertically because we've gone down the hypotenuse, and we're looking for the amount of horizontal change, which is this distance here. Now, we can't do Pythagorean theorem because we don't have another side length or an angle or anything like that. But what we can use is our slope, or 12% grade. Now, if we take our slope and set that up as a rise over run situation, we know that we have 12 vertical feet for every 100 horizontal feet change. So what I notice here, and you're going to have to think back to geometry for this, is it looks like we have two similar triangles. So if I have two similar triangles, I can set them up as a ratio of x divided by 2,000 is equal to 100 divided by 12. And you can set it up in a multiple of different ways. But now what I can do is I can cross multiply. So if I cross multiply, I'm going to multiply 2,000 by 100, set that equal to 12 times x, and that gives us 200,000 is equal to 12x, and when you simplify this, you end up with x is equal to 16,666.7 feet. And that would be your final answer then. Example 6 says that the following are the slopes of lines representing annual sales y in terms of time x in years. Use the slopes to interpret any change in annual sales for a 1-year increase in time. So when we look at part A, it says the line has a slope of m equals 120. Well, because we're talking about sales and I have a positive slope, that's going to tell me that I have an increase in sales by 120 units. And because it's on a yearly basis, we'll say per year. Part B, where we have a line that has a slope of m equals 0, well, a slope of 0 means that I have no increase and no decrease. So this means that I have no change in sales. I did the same thing this year as I did last year, so there's no change in sales. In part C, it says the line has a slope of a negative 35. Well, negative slopes usually tends to mean that we are decreasing in value. So this here would be a decrease in sales by 35 units per year. And our last example says, a person purchases a car for $25,290. After 11 years, the car needs to be replaced and has depreciated. And if you don't know what depreciation means, it means that it decreases in value. So our car has depreciated at $1,200. We want to write a linear equation to represent the value of the car. So the first thing we're going to need to do is we're going to have to put a time. We're given 11 years after we purchased our car has a value of $1,200. Now, even though it's not given to us, we can associate a time value with the initial purchase of our car, because that would be on the first day we got it, or when t equals 0, our car was worth $25,290. Just like when t equaled 11 years, our car was worth $1,200. Now the reason we want to do that is because now I really have an x and a y and another x and a y. So I'm going to write these as coordinate pairs. So I have 0 and 25,290. and I have the other coordinate point of $11 and $1,200. So now if I have 2 points, I can go ahead and write an equation to represent the value of my car, because 2 points will give me a slope, and then I can find an intercept. So to do that, I'm going to go ahead and use my slope formula. So M equals, and I'm going to go ahead and call this my x2, my y2, this will be my x1 and y1, and it doesn't matter, the numbers will work out the same, but I end up with 25,290 minus 1,200 divided by 0 minus 11, and 25,290 minus 1,200 is 24,090 divided by a negative 11, and if I simplify that, we end up with a negative 2,190 for a slope. So a negative slope, remember, means that our value is decreasing. So in other words, I'm losing about $2,100, almost $2,200 a year on that car. Okay, so I've got a slope now, and if I want to write my equation, all I need to do is use my point slope formula, and I'm going to use my first point here to plug in, so I have y minus 25,290, and that's going to be equal to my slope of a negative 2,190 times a quantity of x minus 0. So to find the equation, I'm going to distribute, and I see that this is, because of this 0 here, that term's going to go away. And then I'm going to have to add this 25,290 to the other side. So I end up with an equation that looks like y equals a negative 2,190x plus 25,290. And this right here would be the linear equation that represents the value of that car. Okay, in this table here is just kind of a summary of the different equations that we've dealt with in Algebra 1 and Algebra 2, and that we're going to look at again in Precalc. The standard form or general form of a line is this ax plus by plus c equals 0. Remember, if we have a vertical line, the equation is x is equal to some number, or a in this case. The equation of a horizontal line is y equals a number, or b. Slope intercept is y equals mx plus b. We went over point slope form. Now, the point slope form and the 2-point form are really the same thing. The only thing is here you're given the slope, here you're having to calculate it, but it's essentially the same equation. So if you have questions on these, or you don't remember how to do them, please let me know. And today's fun fact is another cartoon. So if you have questions on it or again need explanation, let me know tomorrow in class. And with that, have a good night, and I will see you in class